so I wanted to make a quick detour of a side project we have, which is called Connected Pick, which was created by one of our developers in his spare time. So it's a fun side project. It's nothing meant to be production use. And our benchmark for this tool was, okay, we take a software developer who has no idea about physics, we give him a 1-hour lecture on photonics and how our tool works, and he can start creating picks using it. That was just what we thought would be a fun idea. So what we want is a simple intuitive interface with a 5-minute learning curve, drag and drop design methodology, instant feedback, all that good stuff. What we don't want is to replace any professional tools. We don't want high complexity in this tool, and yeah, we want it to be open source and all that stuff. Now, this tool doesn't necessarily relate to what we were talking about earlier, because this does have the idea of a standard cell, but not on the scale of what we actually want. It is meant to be a stepping stone for us internally, how we think about standard cells. And the concept is very simple. So you have this grid of cells. You have a fixed place where you have your couplers, could be graded couplers, edge couplers, whatever. And then you start placing either waveguides, you place some couplers, etc. And then you have your mass center and it's done. Very simple, very simple. And the way these cells work, you have your standardized cell size, you have a visual representation of what it does, you have maybe some slider to adjust the coupling of the cell. You have an S matrix for simulation purposes, and you have the ability to export it to a GDS file. And here are just some examples. You could think of anything. You could even think of full mass centers as a standard cell. You could think of AWGs and all that fun stuff. And yes. So this is what the tool actually looks like, right? We made it look like a game because we wanted it to be approachable also by students. And we think with Gen Z, yeah, the attention span is best kept with a gamified version. So this very simple tool here, you have a mass center, you have your ring resonator, and simulation is simply done by switching on the lights, and then boom, okay, you have 2 different wavelengths coming in. You can do some interference, you can do some simple, very simplistic, quantitative results from that. So now you're filtering out the blue light later. You can also change the length of the ring to, for example, filter out the red light. Yeah. You get the picture. It's very simple. That's how you use the tool. You can freely design stuff very fast, right? You can place your elements everywhere you want. It's meant to be simple. And the cool thing is you can export it to Nazca, so then you would get something like this. And you see this Nazca code looks very different to what you're usually used to in PIC design. It's just the standard cells everywhere and nothing special. Finally, when you create the GS file, it looks like this. And you have your PIC design ready to go without ever having to think of where do I place my waveguide, where do I place that. It's very simple. Of course, you wouldn't fabricate this. It's a huge waste of space. But yeah, to get to know PIC design, I think this is a fun tool. It's open source, so feel free to try it out. Good. And some of the implementation details, who of you are wondering, we did not use Python because Python, it's very hard to create large-scale software tools with Python. So we use C# using the Godot engine. This is a regular game engine, so yeah, it's actually meant to be a game. It's fully source controlled using Git. It's fully, at the moment about 50% test coverage, so that we know that the tool works. It has a full CI/CD pipeline in GitHub Actions, and of course, free to download it and play around with it. It has an MIT license, so if you want to put your name on it, that's perfectly fine. We don't mind. It's meant to be for the academic crowd. So, some quick conclusions. This quick detour was just to show you that the standard cell approach isn't too complicated. It's not really a huge step forward. It's just a different way of how we think about PIC design, and something we hope will be the future of how we do system-level PIC design. And PIC design can be extremely accessible if we don't force the user to learn about all the physics, all the photonics, and just think about what does he actually want to do with the pick. And designing picks can be easy and fun. That's why this talk was originally, or is titled Quick and Dirty Pick Design, because you can just click around and design your pick and you're done and happy. We should start focusing on the system level pick design, and that's the main key message on this talk. And we should stop trying to reinvent the wheel with the foundries. We should stop asking them, hey, can you add 10 nanometer to your quantum well or something like that. All these weird kind of requests you sometimes see out there. And yeah, Connected Pick goes as a big brother, which actually can do everything I just talked about, but that's just an in-house tool, sorry. I just wanted to show it. Good. So, thank you very much, and if you're interested in talking with us about defining the next generation of computers, the all-optical computers, I'm happy to do so.